Hi guys, good afternoon. Can you hear me? Hi, can you hear me? Good afternoon. Is it my network or Hi Zainab, Olariwaju, can you guys hear me? Wait for someone. Hi, can you guys hear me? Hi Zainab, can you hear me? Good afternoon. Hi Zainab, hi Victor, can you hear me?
Hi, yes, I can. Good evening.
Okay, good afternoon. All right. So welcome to today's live coding session. Can you guys see my screen? You can just drop a chat if you can see my screen so I can start what we have for today. All right, thank you. Mm, so welcome. This is the first live coding session for your track, and I hope you guys have been going through your courses, your stage B course, and I hope you have been finding it easy. Um, as the name of the course implies, data storytelling. So basically, looking into insights and visualizations can be performed on data sets for real life scenarios. So for today, we are going to be looking at an extension of what was done in stage A, because in stage A, we spoke extensively on pandas visualization a bit, and this is just going to basically be a recap for a new data set for what was done in that stage. For this stage, we are going to be making visualizations for electric vehicle data sets. The electric vehicles have been like the new thing in town, seeing as the price of oil due to the wars and stuff between Russia. The situation of the world today has started making countries look into the avenue of creating sustainable electric vehicles. So we're just going to be doing a short. It's going to span because each track has two live coding sessions. So this is the first one. The date and time for the second one will be communicated. Might be tomorrow, might be next tomorrow, where we'll try to visualize insights from a data set on electric vehicles. And the stage B entails using Microsoft Power BI. So Power BI is another great tool for visualization that does not require a lot of coding as it would in Python. Since Python is basically coding, Power BI is more like a no code tool that you can use to perform the same sort of visualization that you would in Python. So if you guys can see my screen, so this is data set that we're going to be using for today. So the data set is a data set on electric vehicles, and so the data set contains two data actually. There's one that is normalized and there's one that is clean. So as a starter, because the essence of data storytelling and data visualization is to try to be able to gain insights from the data, because as we have stated previously, it is not just how do I put it? What's the word now? Working with numbers alone might be a little bit bogus in a way. So visualizations of data sets help us to draw those insights quickly and be able to make inference based on what it is we are saying. It is easier to capture and analyze visual data than it would be to compare numerical digits. So the data set is this on EV, and the data set has been downloaded on my local PC, just to confirm that. Okay, so I have to download it. So okay, let me just run this quickly. So seeing as the reason why I'm not the way I like to do it in a practical manner, because as I normally say, not everything can be known off edge. So that's why most of the time when we're working on live coding sessions like this, I try my best to not over prepare before the live coding session, because I like to showcase how it works in real time, because it's there's this conception that the coding is always perfect on the first trial and all of this kind of stuff. But when you're working with data sets and all, you have to do a lot of trial and error before you can get the best before you are able to get the best version of whatever it is that you want to get. So I've actually the data set is actually on another account. So just give me a few minutes to get the data set up and running in my cargo data sets in my collab notebook, sorry. While I'm doing that, if there's any question that you have currently on maybe you have any question on the stage, the internship, or anything that you want to ask, you can ask for that, as this is a track stuff. So people in each track are meant to work together and try to bond together and help each other. So if you have any question on the track, any question on data storytelling, anything at all, you can just drop it while I work on extracting this data. Okay, I see no question at all. All right, so I'm done with that. So let me import the data into my notebook. Okay, so the data set has been imported. These are the data. So the first column um, is the where we make our import. So as usual, we'll be importing the usual libraries, importing numpy as np, then we're going to import pandas as pd, then import matplotlib. So these are standard libraries that will always be utilized by any data storyteller if you are going to be doing your visualization with Python. As plt, import cborn as sns. Okay, so I don't know why this is saying. Let me just stop this one time. Okay, I don't know what's wrong with this one time. So let me just disconnect the one time. Okay, and then let me connect again. So I'll need to re-input the data set. Okay, so this code should run successfully now. Exactly. So this code has run. So the first thing we're going to be doing is we're going to be reading in the data as usual. So read CSV. So I'll just copy the name of the data set from here. Copy paths. So this is the clean data, and then I'll load it in. So this data set has been loaded in successfully. So if we check the size of the data set, it has just 103 rows and 14 columns. So this data set, if we go back to this window where we got the data set from, you see that it was specified that this is a smaller version of the data set. So there's actually a larger version which one can use for more data, for more insight, but just for the purpose of this just for the purpose of this demonstration, we decided to use this smaller one just to showcase the different kind of visualizations that we can perform. So this is the data set, and this is the clean one. So as usual, okay, I did not assign this to any variable. So df is equals to with this. So let's do our normal checks on the data sets. As the info.
Hi. Hello.
Hello, yes. Your line was breaking.
It's like your okay. Sorry, I don't know if it's from my side, but your screen is frozen. Could it be from my side?
Um oh, okay. How about now? Can you guys see the screen now?
Yes, and I requested for the link to the data set we're
Data
using.
sets, yes. Yeah, all of this will be dropped on the track after this live coding session.
Okay, what about us that want to follow through with you? Maybe we should just watch.
Um yes, I it is not going to be a long session. You should in the next 20 25 minutes, max should be 1 hour, will be done. So the video is being recorded, it's going to be on YouTube. So
Okay.
um you can just follow along. But I get if you might want to follow along. So
Yes.
I'll say I'll drop a link to the data set here. But
Okay.
I'll prefer if you can just like do this in your leisure time later, and then work on this in your spare time, while you can also refer to the video that is going to be it's going to be recorded and it will be on YouTube. But the link to the
All
data set
right.
has been already.
All right. Thank you so much.
No problem. So as usual, the first thing is the info, and we can see that okay, there's no null values as expected. Then apart from that, let's do a describe on this, and let's see what will come up. So we're expecting just 1 2 3 4, a few of the columns will show. So we can see that for the acceleration, so we'll check out the meaning of all of this in real time, but these are the numeric values that we have in the data set. So going back to the data sets, um we that in any data story, in any data storytelling, um in any data storytelling or any data analysis project, there will always be at least a starting point where you have an idea of the kind of visualization it is that you want to perform. So that is what some of the basic tasks. That's what these are the pointers we are going to be starting with. So the basic task number one: what car has the fastest 0 to 100 acceleration? So we'll be trying to answer all of these questions using visualization. So data storytelling is a way to create questions from the data and use visualizations to answer those questions, which will make it understandable to a layman. So, for example, this kind of projects we have seen for mostly people that are in Nigeria would have had where the new talk about electric vehicles, saying that they want to create conversion models and all of this stuff. So this can be a way for someone to pitch that, okay, based on the electric vehicle data sets we have on the world, these are the things that we are seeing. So you can say, okay, these are the things that could be avoided. These are the techniques that have been done that worked, and all of those kind of stuff. So as I said, we'll be starting with this basic 1, 2, 3, 4, 5. So after doing that, we'll then try to move on to we'll then try to come up with questions ourselves and then answer those questions. Okay, so I'm trying to see if there's a place that's okay, exactly. So this is what defines all of the columns. So let me select all the columns and apply, so we can see the meaning of all of the columns. So this is the brand name, the brand for the electric vehicle, the model name for that car, the acceleration between 0 to 100 km/h, the top speed for that particular car, the range that electric vehicle can go for, the efficiency, fast charging, um if that electric vehicle can undergo rapid charge. So if there's a powertrain, the plug type, the body style, the segment, the number of seats for the EV, and the price for that electric vehicle. So based on that, so we see that the max acceleration is 22.4 km/h. The top speed, the top speed that the highest top speed that we saw that is existing in this data set for any type of electric vehicle is 410. The range 970 km before the battery life runs out. Efficiency is at 273. The number of seats, highest number of seats, there's a 7-seater electric vehicle, and the highest price is I think is 215,000 euros for the electric vehicle. So these are the like basic things in the data that one can look at. All right, so oh, so I was talking about this aspect. This is the describe. So we can see that the highest range is 970 kilometers. The highest top speed for any EV is 410. The maximum acceleration is 22.4, and the highest price for any EV is 215,000 euros. So just to make our life easier, let me just go back to this and copy those 5 tags. So I'm going to bring them here, and let me just add them here as a text and paste them. So this is number one, number two, number three, number four, and then number 5. Okay, so exactly. So let's go. Since there's no value for us to work on, then we can start answering this question. So let's see. What car has the fastest 0 to 100 acceleration? So what we're going to do is we're first going to be working on all of this one by one. So we're going to go to the DF model. Okay. So DF model. So when we do DF model, saying that there's nothing like that. Okay, it's a capital letter M. So I'm going to come here, change this capital letter M for model. So you can see that we have different type of models. The model long blah blah blah. These 102 models. So if there are 102 models and we're trying to plot, should we try to plot the price for each of these models? What would be the best plot to do something like this? Saying that 102 models is quite large. So if we are plotting a price for each of these different models, it might be a little bit bulky on whatever plot we want to plot. But let's just see how it goes. So let's do a plot.figure. So plot.figure is a way to feed. So we always assign the plot.figure. So one thing, as I always say, is we should be able to work with documentations a lot. So when you're able to work with documentations, you'll be making a lot of researches when you're working, because it is not possible to, as I'll keep saying, it's not possible um to have all of these in one's head without having to refer to the documentation for those that created this, or to the documentation for how to use these methods. So what all you just need is the basic idea of how to go about whatever it is that you want to do. And when you have that basic knowledge, you'll be able to configure and work with whatever data set that it is you want to work on. So as I was saying, so we said we want to plot. So this, okay, before I go into the plotting, let's just answer this. What car has the fastest 0 to 100 acceleration? So what we first have to do is we have to go to the 0 to 100 acceleration. What's the name of that column? That's this column here. So let's pick this column. Okay, so that's this column, and get the maximum value of this column. So we can see that the maximum value of this column is 22.4, just as we had it here, 22.4. Okay, so let's assign this to max acceleration. Okay, so based on the max, what's my keyboard doing like this? So max acceleration. So we already know that's for max acceleration. So then we now need to get the model. That it's what is speed. So what I'm first going to do is I'm going to say df model, this column here, Ctrl Z, Ctrl C, is equals to our what, max acceleration. So when we do this first, we'll see what a lot of false and true. So a lot of false and true, but we don't actually know it. So the correct way to do it is you have to use this what is being this boolean that is being returned here. You can actually use it to get, you can get just the ones that are what, that are true. So to do this, all I just have to do is I just have to come here and say df. Okay, and if I run this now, you see that it has returned just the one that is true. That's the model that has the what, the max acceleration. So that's the way for you to know that you can use indexing. You can use like boolean values to index a data frame. So it doesn't necessarily have to be that you are indexing with um things that actually exist, but things like boolean, when you check a condition, so you can use a condition to get all of those rules that correspond to that condition in a data set. So based on this, you have seen that the brand with the model with the highest acceleration is the what, is the Kangoo Mazi ZDS3. So this is the electric vehicle that had the highest acceleration in this data set. So to do this with utilization, so let's just do a plot.figure, and we're going to set the fixed size. Let the fixed size be 10 by 10. Okay, so now let us use SNS, but let's do an histogram where what that we are going to be plotting the models and the price. So let me try this first. So there will be a lot of, okay, so I want the x to be the model. No, I want the x to be the acceleration sec, and I want the y. I'll tell you why I'm doing that in a minute if this eventually works. And I want the y to be the what? I want the y to be the model, and do this for data equals to df. So seaborn, okay, I think this should be east plot. Okay, so um exactly, as you can see, this is why I wanted us to have the X on this. You can see that all of these are mumbled in together. They are mumbled up together. Why? Because it's too much. It's 103 stuff, and it's trying to put it into this what? Into this 10 by 10. So let's see if we increase this to 20 by 20. Let us see if it will be able to fit all of these 100 and something stuff. So you can see now that it's very better now. It's bigger, but it is better because all of these are what? They are they are not now mumbled into each other. So I think 20, I can go 18 by 18. Okay, so this work exactly, at least this is working also. So based on this now, we can see that for the acceleration sec only, but it is not really is this visualization now, although it showcases what we want, it has not been able to it has not been able to give us a visualization that let us know that it is the Kangoo Maxi ZD. Let us look for the Kangoo Maxi ZD. If you look for the Kangoo Maxi ZD, where is that? um as you can see, this is not really a visualization that showcases what it is we want to show. So let us try another approach. Another approach, leaving this figure here, is that we can do a bar plot, plt dot bar plot. Okay, so when we do the plt dot bar plot, we are going to be plotting the acceleration sec ACC. So when we plot this acceleration sec, so that's, I'm trying to do this to let us know that it is not something that comes at once. It's just something that you have to know a lot of techniques for this visualization, and when you understand these techniques for visualization, you'll be able to what come up with a solution eventually. So it has no okay, it says it has nothing called bar plots. Bar plots. Okay. Oh, so I'm giving it the X, I'm not giving it the Y. So let me use, because I want to show us something first before I begin to use the letters. So let me see if SNS bar plots will do what it is that I want. Okay, this is definitely not what I want also. So okay, to do this, let me do a range, okay, 0 to df dot shape and 0 comma, then this is the height. So now let us run this. 0 to 1. Oh, but 2 were given. I see, I'm coming. PLT bar. Okay, so exactly, this is an example of what I want us to show. So as you can see now that this is a bar plot. Let me try to increase the figure of this again to 20 by 20. So this is a bar plot, yes. And you can see that for each bar plot, the acceleration spec value is it. So the Y is the acceleration spec value, and the X is just different things. So the arc I did now, you see that this goes from 0 to 20 to 40 to 60 to 100. So what I did here now was that I said I want to plot a bar plot, but I knew that the using the bar plot, the way matplotlib plot is bar function, is that it requires you to give it X value and the Y value. So I did a hack just to confirm that what I'm trying to do is going to work in the end here. So I said that this range, so just give me values from 0, 1 to up to what? Up to 102, which is the number of the what? Number of the rows we have in this data set. That's df.shape 0. So now what I'm now trying to do is that rather than using the model name, I'm just saying that for each row, just plot out the acceleration spec value of that row. Okay, so that works for now. So what I need to do now is, instead of now making these numbers, I now need to replace this with the what? the model. I now need to replace this what, instead of it to be me saying that this is 0 to 102, I now need to replace it with the what, the model name. And there are multiple ways to do this. Let me try this one first and see if this will work. So what I'm just going to try first is I'm going to see if just saying that let this be the what, the model name, okay, and then let the y be the what, the acceleration spec, and let us see this if this will work. So if this works, you can see now that we have, this is what doing what you expect it to do, but as expected, the names are long, so it is clashing with each other. So what do you have to do? We need to rotate the ticks. So what we're just going to do is say plot.x ticks, then rotate equals to what, 90. So when we do this and run this, I think it should be rotation. I think it should be rotation, exactly. So when we do this and run this, you can see now for this visualization that we have here. So what we just have to do is to look for the what, look for the longest what, the longest bar, and any model that corresponds to the longest bar is the bar that has the what, that has the highest visualization in the, that has the highest what, acceleration in this data set. And going down, following this long bar, just following this bar down, we can see that what, this bar corresponds to the what, the Kangoo Mazda EZ something. So maybe doing it this way might even look, it's making it seem they are all bundled up together. We can change the orientation of this data set. So rather than, let me just comment this out. So rather than letting this be the X value, I'll let this control X. I'll let this now be the X, okay, and then let this be the Y. So if I do it this way, the orientation of the data set will be what, will be changed. Okay, this is definitely not what I want. I wanted an horizontal bar plot. So I think, let me try to say bar H and see if this will work. Exactly. So all I just have to do now is to go back, Control X, a comma, then Control V, and then run this. So this is an horizontal bar plot. So what this will do now is that you can see now that the model names are now on the x-axis, and the what, the value for the acceleration spec are now on the what, x-axis, on the sorry, the value for the acceleration on the x-axis, and the model names are now on the what, on the y-axis. So now with this, it might be a little bit better it might be easier to just what, just look at, okay, this long bar, follow it straight down, and we can see that it is the what, the Kangoo Maxi ZE3. We have been able to answer this number one. Rather than showing just number, we have been able to showcase it with what, with a visualization that shows that the Kangoo Maxi XE3 has what, a very, it has the max what, acceleration compared to every other model in this data set. That's for number one. So that's the fastest. So if they say for the highest efficiency to just follows the what, just follows the same pattern. Let me copy this code here and then come here just to do the same thing. So let me say max efficiency. So what's the efficiency column? The efficiency column is this column. So I'll just copy this down to, and then paste the efficiency column what here, Control V. So after that, I just have to say that what efficiency is equal to the what, the max efficiency. So once we do this, we can see that the data sets with the max efficiency is what, it is this the model with the max efficiency, sorry, it is the what, the EQV 300 long. So its acceleration is just 10. It has a top speed of 140, but the efficiency is what, 273, which is the what, the highest that is existing in this data set. So to showcase this with the visualization again, we could use the exact same visualization, but another one that we can use is we can try to do this using a pie chart. But due to the fact that we have 102 models in this data set, using a pie chart is not going to be the best, because no matter how large you make it, 102 models in a pie chart that is trying to show a percentage will do what, will be mumbled up. The pie chart has to be either very large for you to have something like that. So just following this convention, yeah, I'll just copy this code again and paste it here. But what I'll just do is I'll make it a little bit finer now. So when I'm saying fig equals to something, I'm going to specify a color. So I should be able to specify a color. And one thing we should note about matplotlib is they were created by Americans. So British spelling for color has a U, but the color, yeah, is is the color without a U. So let me see and try color red, and let us see what will happen. So with color red, you can see that okay, this has been changed to red here. So instead of this, so I'm not going for the model now. So I'm still going for the model, but instead of the model this time, what are we going for? We're going for the what? The efficiency. I'll pick the efficiency on V, and now I'll now add what PLT dot title. So because if someone comes there now, you are the only one, I'm the only one to understand, we are the only one to understand this visualization. Why? Because we have not added any description to this visualization. So that's what we're going to try to do here. So PLT dot title, PLT dot title, okay, equals to, so we're going to title this the highest efficiency in the data sets. Okay, so as there is, so PLT dot X label. So the X label is what? So what's on the X axis? The X axis is the what? The efficiency. And PLT dot Y label. The Y label is the what? Is the model. So if we run this, we have no error. We'll see that our data set will now be what? You can see now the title is the what? The highest efficiency in the data set. And on the x-axis, we have these are the what? The models. And on the x-axis, we have these are the what? The values for efficiency. And the longest bar for efficiency, though it is not looking too clear as the last one, but the longest bar for efficiency is most likely this bar. And if I trace this bar straight down, you can see that this is the EQV 300 long. So this is what for question 1 and what and for question 2. So let us move on to question 3. And what does question 3 ask us to do? So I'm just going to close all of this so I'll not have too much. Does a difference in powertrain affect the range, top speed, or efficiency? So now we have moved from what? Visualization from one a single variable visualization to multi-variable visualization. Okay, so now we are trying to see if there's a sort of correlation where one variable is affecting another what variable. So the easiest way to do this, is to just do the what? The correlation. So to make to not have,
Excuse me, sir.
okay,
I have a question.
I can hear you. What's the question?
Don't we, for the plotting for the chart, can't we kind of sort it? Maybe the highest, the highest
Yeah,
until
definitely
we get
that
it.
can be done.
Okay.
That can be done. So to do that, you just have to ensure, because of the way we are plotting it, because you understand that the way I'm plotting, I'm not plotting both of them in conjunction. So if I sort this independently, yeah, I have to also make sure I'm sorting with relation to this. So one way to do that, let me do it for this data set here, is I'm going to come here. So for this, I'm going to create a new DFC, df underscore c, and df underscore c will contain, can you please mute your mic so it doesn't affect all of us? Thank you. So df underscore is going to contain dot model and what? The efficiency in watt hour kilometer, I think. Okay, so that's df underscore c. So df underscore c dot sort values and I'm going to sort it by the what? I'm going to sort it by the efficiency. Control V. So let us run this code now and see. Okay, this has to be in another list. Okay, so you can see now that the efficiency has been sorted. So let us go from top to bottom, which is the what? Ascending ACN is okay, exactly. Ascending is equals to what? False. So we do this now, so you can see that we're starting from the what? From the list efficiency. So with this now, we have sorted the data sets together. So now that the data set have been sorted together, so what we just have to do now is to just, instead of saying df underscore, so see what we'll be taking here now is df underscore c model and df underscore c efficiency. And now we will plot this. We'll see what is sorted plotting, where the first, did that work as expected? No, that not as expected. Oh, because I sorted it, but I did not save the sorting. So I'm going to save the sorting now. df underscore c is equals to this dot reset underscore index. Okay, so now if I run this code, you should see a sorted plotting where exactly it is going from the what, from the least to the largest. You can see now that the highest is the last one, the EQV 300, and it is the what, that's the highest efficiency in the data set. So that is just a better way to even show this visually, and the same can be done for even this. That's I think that's for the acceleration, so that can be done also. So in the case where you see that this, but I don't think I needed to sort for acceleration, as the result of the acceleration was glaring from the bar plots that that model of car had the highest acceleration in the data set. So thank you for that contribution also. Okay, so another one that, okay, I think we were on question 3, where we were saying that we have gone to what, this C, and then, so let me just paste the question here. Control V. So does a difference in powertrain affect the, so exactly, so this is the question we're trying to solve it now. So there's a difference in powertrain affect the, so the first thing we have to do here now is we are going to take a df, let's call it sub a, and what this will contain is the what, the powertrain here. So let me just check all of the column names. So I take this. So this powertrain number 1. Then after powertrain, what else? Top speed. So let's us work with top speed first. What's the top speed? What's the title of the column? So that's top speed kilometer hour. Okay. So let's do this here. Control V, and let's run this. So you can see now that, okay, so once we have taken this df sub, so for on this df sub, we can do a correlation. So what's happening? Df sub is not containing. Oh, I see. So this is a categorical in a sense. So let's say call should be the include equals to all or something. Okay, let me just look for that. Include categorical, because when I am working, I don't like including both categorical in the same categorical variables. When I'm doing a correlation, done I prefer to have done a type of encoding I prefer to have done a kind of encoding, and it's in that encoding that I will now use to um like perform the correlation and stuff. So it is saying that I don't think there's the include option for this. I don't think there's the include option, because if we did a describe and we there's the include is equals to all for the describe. So this will include this, but I don't think there's a describe for the correlation. So the first thing I'm going to do to see the correlation that is existing is I'm going to encode this. I'm going to encode I'm going to encode, or rather than encoding, I'm just going to do a group by. So the first thing I'll do is in the df.sub.group by, so I'll group it by the what? I'm going to be grouping it by the powertrain. Okay. So after grouping it by the powertrain, let us just see the counts. So we can see now that after grouping by the powertrain, the let us do a sum rather than a count. Okay, so we can see that for after grouping by the powertrain, the sum for the top speed for the AWD powertrain is 8,000 plus, while the sum for the top speed for FWD powertrain is the what? Is around 5,000, while the least powertrain that we can see is the what? Is the RWD powertrain, and comes the top speed just comes at what? At 4,060. So this is, we have seen that a difference in powertrain affects the top speed. So rather than those top speed, let us even include other, sorry, let's include other columns also. That's the range and the efficiency. That's the range and the efficiency. So let us include the range and the efficiency here. Okay, and then the efficiency. So now let us, okay, Ctrl Z, there should not be a space here. All right, so now let us run this, and we can see now that for the efficiency, it is also the same story. For the range, it is also the same story. So the AWD powertrain has the what? The highest values across the board, and the across the board for both the top range, the top speed, the range, and the efficiency. So we have been able to see just from this one that we just did there, we have been able to see that a difference in powertrain does affect this. So how do we answer this visually? How do we put a visual picture out there for this? So one thing that we can do is we can do a we can do a subplot side by side. We can do a subplot side by side to show the different values of the top speed for each of these powertrain. That's one thing we can do. Another thing we can do is we can use a pie chart, and in that pie chart, so we'll draw a pie chart. Just before I can say if we can use a pie chart, let me just try something. So let me do a sum of the top speed. Let me just copy this, Ctrl C. So let me do a sum of the top speed, Ctrl V, and enter. So if I do a sum dot sum, this is 18,457. Okay. So to just do this, so let me do a this, let me just pick this to not disrupt what we have here. So let me pick this here and pick the top speed also. Control V. Then I have to come and copy and paste again. Control C. And then this is Control V. Okay. So if I do this, we can see that we have these three have been selected. So let me do a sum of these three. So if the sum we have here, so you can see the sum we have here is the same as the sum of what we have here. So basically what I'm trying to say now is we can do a pie chart where the pie chart will be a total of what 18,457, and then we'll now start giving portions to either AWD, FWD, or RWD based on the percentage of whatever that takes. So let us do that as the last visualization will be taken for today. So when we come back next for our next live coding session, it is most likely going to be tomorrow. If it's not tomorrow, but the time and date to be communicated, but I feel it is most likely going to be tomorrow. So when we come back for our next live coding session, we'll take a bit more. We'll answer the two other questions and try to say a bit more on other type of visualization that can be done. And then we'll just say a little on Power BI. Power BI is not my specialty because I don't use no code tools, but Power BI has been seen to be help a lot of people. So I will try to say the best I can and then give, because I think Power BI is free as compared to Tableau. One of them is, I think Power BI is free, while Tableau is not, or one of them. But we'll talk about that in the next live coding session. So to do that, we are going to be working with this. We are going to be working with this data here. So let me just see. Let me see if we can do this v dot sum dot top speed. Okay, let me just copy this and see if we can do a df dot plot, because I just want to confirm if this. So let me just see dot plot kind is equals to pi. So if this does not work, then we'll use the automatic. This worked perfectly. So you can see that I wasn't expecting it to work on the first time. Actually, I was thinking I was going to have to use the manual pi, but the guys that came up with pandas and stuff, they understand all of this. So you can see that based on this, the AWD. So let me just see if, I think the last time I tried to use this, it did not work. Auto FMT or something was to 0.2, or let me see, auto, I think it's auto PCT. So what I'm trying to do is I'm trying to like, okay, so this should not be, so I'm trying to like write the percentage of what each powertrain is taking from the total powertrain. So we are trying to see that, okay, for each of the powertrain, this powertrain is corresponding to more top speed than the other powertrain. So how this, I don't really remember this. Let me just check auto PCT.
I think it's percentage 1.1 F percentage, something like that.
Oh, I see. All right, thanks. So let me try that. I remember, I think they do 1.f also. We should. Okay, so I need to use percentage 1.f. Let's see if this will work. Oh, I think, yes, I think this is it. So so as you can see, but I was hoping the, okay, then if I think if I put another percentage in front, then this should show the percentage. Work. So let me just remove the other percentage.
Yeah, it says percentage 1.1 F percentage.
Okay, one F, then
Percentage
another
1.1 if, yeah, 1 F percentage. Something like that. Did you get that?
okay, yes, I think I did. I think
Yeah,
I
well
did.
then.
So, Yeah, but that's I'm trying to okay exactly. So thank you for that. So we can see now that the AWD powertrain corresponds to 48% of the total what top speed that we have in this data set. So once you are in the AWD powertrain, you belong to the what? You belong to 48% of what? You have a 48% chance of having what a top speed based on this data set. But if you are using the FWD data train, it's just 30%, and you are using the RWD powertrain, it's just what 22%. So we can repeat this also from just if I just do a copy and paste of this code here, and then come here and just do um so what I just have to do is to just df.sub. So when I'm selecting powertrain.sum, so instead of selecting the top speed, what I'll be selecting now is the what? The range. I'm going to come here, change this, and this is now the range, and then one the exact same code, and this will work for the range. You can see that for the range, the AWD even takes what almost 50%. LWD is 28%, and then 21%, and then for the last one, which is for just the efficiency, say okay, and then come here, pick up Ctrl C. So I'm just going to change this V efficiency, and this should do nicely. So this in the way we have been able to showcase that there's actually based on the powertrain that you belong to, there's what the top speed, there's a there's a correlation. So another way to easily show this is with the correlation, and that's where we start from in our next live coding session. So this notebook will be shared. You guys can work with this notebook and even try to do a lot of other visualization on your own. But on our next live coding session, we'll be starting from trying to also prove this answer here with another type of visualization, which is the correlation. So we'll try to see how the values of for a particular powertrain, or let's say what we're going to be doing is we'll be selecting models. You can select like 5 models, or based on the different type of models. Based on the different type of models we have in the data set, we have 100 and something models. So just to not make it too I think instead of models, we can group them rather than models. We can group them by the brand. So what we'll now do is that for each brand, we'll now plot the what um the we'll plot the powertrain, and then the powertrain for each of the different powertrains. So let's say, for example, we take Tesla brand. So for the Tesla brand, we'll plot all of the values for the what? The AWD correlation to the top speed for Tesla brand. Then for that same Tesla brand, we'll plot all of the RWD for Tesla brand, then the FWD. So based on this, we'll be able to see that, okay, for each of these different bands, when the powertrain is at 49%, what's happening to the top speed? For each of these bitchain bands, when the powertrain is FWD, what's happening to this speed? That would be another way to visually showcase that the powertrain is having an effect on the what? The range, the top speed, or the efficiency of that what? Of that electric vehicle. So with that, we have come to the end of the live coding session for today. If you have any question, you can ask your question. But if there is no question, then we can just any other question that pops up, not now, you can just drop it on the track. Will be on hand to answer. And anything that is Amoye related, you can send a mail to help@amoye.io, or ask on the Ask Amoye team channel. With that, we have come
Okay.
to the end of today